Hello, my name is Cade Nelson, and I'm a Systems Integration Engineer with Apposite Technologies. In this video, we're going to do a quick overview of using the Netropy Cloud Edition Wide Area Network Emulator inside AWS. Some of the things you can do with the Netropy Cloud Edition is application performance testing within AWS with real-world conditions. We can simulate any type of network within AWS. You can easily integrate and automate using our RESTful API, and we're the only enterprise-level wide area network emulation available in the AWS marketplace. Using AWS out of the box to do your wide area network testing is not always optimal because you're going to incur regional costs. So if you have multiple regions spun up, you have to pay for multiple regions. You then have to pay for the traffic that runs to and from those regions. It's going to take you a little while to set it up and get it up and running. And AWS actually does a really good job of giving you a nice, clean network. So it's not very realistic when you are testing within AWS. You're not going to have any loss. You're not going to have any network outages. There's not going to be any packet duplication, and there's not going to be any packet reordering. And your latency is going to be a little bit higher because this is an overlay network, a software layer of networking. With the Netropy Cloud Edition, you only have to spin up one single region, and you can create a global network within that region. You don't have to pay for data leaving that region. All the data will stay within when you do your network testing. We can deploy in minutes, and we can give you real-world network conditions, such as loss, latency, network outage, duplicate packets, packet reordering, and some other stuff we'll jump into a little bit later. So I have the NetropyCE deployed in the US West region. I have three instances. I have the NetropyCE, and I have an Ubuntu 1 instance and Ubuntu 2 instance, and they're all running in the same region on the same virtual private cloud. I have configured Ubuntu 1 to route through the NetropyCE to Ubuntu 2 to do my testing. So let's go ahead and jump in. This is our Netropy Cloud Edition wide area network emulator. This is our GUI. I currently have pre-configured 4 networks. One is called Wi-Fi, and it takes on some Wi-Fi characteristics as though you were on a Wi-Fi connection at an office or a home. I created another connection called SATCOM, which emulates satellite connections. I then created another network which simulates a Los Angeles to New York 50 megabit connection. And then we have a telco T1, like an old school telco T1. So these are just some I pre-made. I'm going to go ahead and make another so you can see how easy it is. Right now, 5G cellular seems to be the buzzword, so I'm going to create a 5G network. I can either come in here and set my own bandwidth, my background utilizations, my MTU limiting, my delay, my loss, network outage. I could set that all myself, but luckily we already have a setting for 5G. We'll actually do 5G bad. So this is a preset, and it's going to take on 30 milliseconds in one direction, 30 milliseconds in the opposite direction. We're going to do 40 megabits up and 80 megabits down. I'm going to go ahead and create that path, and now I see that I have a 5G cellular path. So I have Ubuntu 1 and Ubuntu 2. I'm logged in here. I'm going to go ahead and give a ping to from Ubuntu 1 to Ubuntu 2. About 10. And as we see here, we're about half a millisecond latency. So I want to assign Ubuntu 1 and Ubuntu 2 to use this 5G cellular network. Well, how do you do that? So looking at my network diagram, I see Ubuntu 1 is plugged into Ethernet 1, or port 1 on the Netropy, and Ubuntu 2 is plugged into port 2 on the Netropy Cloud Edition. So I have to remember it. I'm going to go ahead and create an endpoint, and this will be my Ubuntu 1. And here's where it's on port 1, and here's where I can assign it to the particular network path that I want to assign it to. So I'm going to assign it to 5G, and I'm going to tell the Netropy that Ubuntu 1 has the IP address of 10.10.1.10. I'm going to create that endpoint, and now I see a visual rendering in my topology view that Ubuntu 1 is plugged into port 1 on the 5G cellular path. So let's do the same for Ubuntu 2. So we're going to call this Ubuntu-2, and I'm going to assign it to port 2. And his IP address is 10.10.2.10, and he's going to be on port 2 of the 5G cellular path, right? So now I see Ubuntu 1 is connected to the 5G cellular path, and Ubuntu 2 is on the other side on port 2. We don't see any ping times changing or anything because I haven't turned on emulation. As soon as I turn on emulation, take a look at my ping time. Bam, now we see it at 60 milliseconds, and it'll take on the 40 megabits up, 80 megabits down parameters. So let's do that real quick. I'll do an iperf and we'll check. I'll check our bandwidth here. And while that's happening, I can also see the traffic running through. We see here we're getting, a little bit less than 80. It's averaging out close to 80 megabits. Down here you can see it's 73, 83. It's jumping around because TCP likes to ramp up and then ramp down and then ramp up and ramp down. So we can see our traffic running through here. We have our frames, our rates at 80.02 megabits, which is what it's set up. That's our download speed here. So great. So let's say I'm done testing in 5G cellular, and now I would like to test in satellite. So I could simply just edit Ubuntu 1, assign him to satellite, apply change. Let's set Ubuntu 2 and apply him to satellite, apply change. And now we see our throughput has gone way down. Let's do a ping and see what our ping looks like. So here we're seeing 1.5 seconds, 1.1 seconds, 1.2 seconds. This is called jitter, right? So if we look at the settings, we can see that we have jitter anywhere from 450 milliseconds in one direction, 450 milliseconds in the other direction. So 900 milliseconds round trip to 2 seconds round trip, and it's jittering. It's giving us packet reordering. It's also giving us a little bit of loss. And just for fun, so you guys can watch, I'm going to go ahead and do some packet duplications. I'm going to give a 70% likeliness of getting packet duplications. So if I hit apply, you watch down here, I should start seeing duplicate packets. There we go. There's a duplicate packet. There's a duplicate packet. Yeah, so now we're seeing duplicate packets. I'm going to go ahead and turn that off. No reason to have duplicate packets. And again, I can move these around anywhere I'd like. I could move them at will. Maybe I have a one-to-many setup. So maybe I have a Ubuntu-3, and his IP address is 10.10.3.10. Create endpoint. Oops, what didn't it like? Oh, helps if you do a correct IP address. There we go. So now we see we can do one-to-many. I could have even Ubuntu 4. And his IP address is 10.10.4.10. Great. So that. And then maybe it's many-to-many. So maybe on backup server, and his IP address is 10.10.10.10. So we can have many, one-to-many, many-to-many. Yeah, however you want to set up, you can have an endless number of endpoints, but you are limited to 20 different types of networks within the Netropy Cloud Edition. So this is creating all sorts of different networks inside of one region of Amazon AWS. You can go ahead and script your changes. You can control everything you see me do in here. You can do via RESTful API as well. If you have any questions or you'd like some more information, feel free to contact us, and that is support@apposite-tech.com. You can contact our sales department by emailing sales@apposite-tech.com. And you can also search for us on the Amazon Marketplace. Just search for Netropy or NetropyCE, and you can start using us. Thanks for the time. Hope to hear from you soon. Thanks.